Welcome. My name is David Gardner and I'm professor of turfgrass science at The Ohio State University. I want to review some of the basics of plant fertility. On this chart we have a list of the essential elements for turfgrass growth, and you'll see that depending on the textbook that you read, there's anywhere from 16 to 18 essential nutrients. Carbon, hydrogen, and oxygen are elements that we don't tend to deal with in our fertility management program, as the plant is able to gather most of these elements from either water or from atmospheric carbon dioxide. They are a major percentage of the plant by weight, since they comprise both the structural and the non-structural carbohydrates, but really we don't deal with them in a fertilizer management program. The primary macronutrients, as they're called, are nitrogen, phosphorus, and potassium. And then the secondary macronutrients are calcium, magnesium, and sulfur. Now, this is not to say that they're necessarily more important nutrients, but they are present in the plant in a higher concentration than the micronutrients, which are boron, chlorine, copper, iron, manganese, molybdenum, depending on the textbook that you read, nickel, and zinc. Now, as we're going to see in a little while, some of these elements are actively used in a foliar fertilization program. Some of these elements, because of their chemical properties, tend to not be a part of most foliar programs. Throughout the course of evolution, if you will, the grass plants and most plants, they evolved mechanisms to acquire the nutrients that they need, primarily via the roots. And soil uptake of nutrients is, even if you are using a foliar program, still thought to be the primary mechanism by which plants acquire their nutrients. And so I want to begin with the discussion of some of the factors that affect the availability of nutrients that are in the soil system. When you look at a plant's roots, there's a couple of different ways that the root can take the nutrients up. One is the diffusion of the nutrients in the soil water. That is, nutrients would be dissolved in the soil water solution, and as they pass the membrane of the root, they diffuse through the membrane and are taken up by the plant. The other way that nutrients can be taken up by plant roots is what's called bulk flow of the nutrients that are moving into the roots. That is, nutrients that are dissolved in the water that's being taken up by the plant are then moved through the root system and up into the plant. Now, when you talk about the uptake of nutrients by the plant root, you have to understand a little bit about some of the soil chemistry that is occurring. See, soil particles tend to have what we call a negative charge. And the reason that they have this negative charge is that most soil minerals they're molecules of silicon and oxygen, and they end up having this negative charge, and that has to be balanced by something. If you didn't have something to balance that negative charge, think about it. When you put the cup cutter into your golf course green, there'd be a blue spark, you'd get blown halfway across the fairway. So there has to be something there that balances that negative charge, and what that is it's cations. And many of those cations are the same things that plants take up and require for their growth and development, such as potassium, calcium, and magnesium. But you see in this diagram here that a soil particle has what we call exchange sites on it, and when you get a soil test, one of the things that is measured is what's called the cation exchange capacity, and that is a measure of the number of these sites that can hold positively charged ions. In this diagram, you can see here that you'd have these negative exchange sites on the soil particle that would then attract certain cations. These cations are not held indefinitely on these negative exchange sites. Rather, they are free to either exchange on or off of those sites, either into the soil water solution, or they can be taken up by plant roots. When a plant root comes into close proximity with the soil particle, that plant root also has a negative charge. And so the cations that are being held by the plant root, such as potassium or calcium, then move off of the soil particle, exchange off of the soil particle onto the root, and are then free to be absorbed by the plant. There's a lot of factors that affect root uptake. One of those is the depth, extent, and activity of the root system. This is one of the reasons that we have so much interest in foliar fertilization on the golf course. As you decrease that height of cut, the plant tends to respond by decreasing the depth of the root system. As you decrease the depth of the root system, there's less root mass that can potentially come into contact with the available nutrients in the soil. Other factors that affect root uptake are the mobility of the nutrient in the soil. Certain elements such as calcium and magnesium tend to be what we call fairly immobile in the soil. That is, they will not move vertically in the profile due to leaching of water or other phenomena. Other elements, though, such as nitrate or chlorine that have a negative charge, since they have a negative charge, they are actually repelled from those negatively charged soil particles, and therefore they are much more prone to vertical movement or leaching out of the soil profile. Another factor that affects root uptake is the energy that's required to take up the particular nutrient. Certain nutrients can move passively through the membrane of the root. Other nutrient elements, though, there has to be energy in the form of ATP that will result in active transport of that nutrient into the root system. If the plant is under any kind of stress, such as high temperature stress like you would see in the summertime, that decreases the amount of energy that is available for the plant to actively uptake the nutrients. And then finally, soil moisture will have an impact on root uptake, because if you have less water available, there's going to be less nutrients in the soil solution for uptake. Some other factors that affect root uptake also are the air temperature. Now, air temperature affects root uptake because as you increase the air temperature, you increase the respiration of the plant. As you increase the respiration of the plant, you decrease the energy that is available for the active uptake of some of those nutrients. Also, the concentration and the balance of the ions in the soil solution. As you increase the concentration of the ion, you increase its availability to plant roots, and on the other hand, as you decrease the concentration, you also decrease the availability of that particular ion to plant roots. Soil pH also has a factor. Because of the way that soil chemistry works, most of the elements that are taken up by the plant for its nutrition are available in the soil solution at an ideal pH, and as you deviate either above that pH or below that pH, those ions actually become tied up in forms that are less available to the plant, or even become insoluble to the plant and unavailable for plant uptake. When you talk about uptake of plant nutrients by the roots, there's a lot of different factors that affect the root uptake. And if you look at this particular graphic here of the nitrogen cycle, the nitrogen cycle is illustrative because we apply all of these other elements in our fertility program and we want to achieve a balance, but nitrogen, for the most part, is the most important element that we deal with in turfgrass management. As you can see on this graphic, though, there are a variety of different things that happen to nitrogen after its application to turf, and there's a host of different environmental factors that will affect the balance of nitrogen and the different forms that it is in. In other words, nitrogen will exist in the soil either as nitrate or ammonium, or it can be tied up in forms that are unavailable to the plant as organic matter. And again, depending on certain environmental factors, there's a big difference in the concentration of nitrogen that are in these different forms. Nitrate in particular is a problem because there has been some concerns in the as far as environmental contamination, not only of phosphorus, that's a big issue in Minnesota and some states in the northern Great Plains right now, but also there is some concern about nitrogen and its potential to leach out of the profile due to turfgrass fertilization practices. So I think this is another thing that is driving our interest in foliar fertilization, as there is some thought that perhaps the application of materials through foliar means may result in more efficient uptake of nitrogen and other plant nutrients. Some factors that affect nitrate leaching are things like the soil texture, the moisture level. As you increase the moisture level, you increase the amount of nitrate that potentially leaches. Also the water table height. The closer the water table is to the soil surface, the more prone you are to having groundwater contamination of nitrate. Also the level of nitrate in the soil. Obviously, as you increase the level of nitrate, you're going to increase the likelihood of leaching of nitrate. And then use by the grass, the rooting depth and the condition of the plant. So you can imagine that in the summertime, on a stressed bent grass green, if you're fertilizing, you're not going to have a lot of rooting depth, and the condition of the plant is such that you're not going to have a lot of energy available for the active uptake of the nitrogen. And so in that situation, nitrogen that is applied could potentially be more prone to leaching. Therefore, again, there has been some increase in the interest of foliar fertilization, not only from the perspective of the efficiency of plant uptake, but also from environmental perspectives. Again, the fate of nitrogen in the soil, it's very complicated, it's very dynamic, it's quite unpredictable, and it's really something that we're just beginning to get a good handle on. Regardless of this, if you are able to apply your fertilizer as a foliar and have uptake by perhaps the foliage of the plant rather than the root tissue, it would take a lot of these factors dealing with nitrogen fate in the soil out of the equation. And again, this is something that has perhaps driven our interest in foliar fertilization.